Hi, my name is Jo Garland and I am a consultant sedimentologist and a director at Cambridge Carbonates Limited. Today we'd like to show you a super quick video of the workflow that we use for evaluating carbonate successions using cuttings. Now, the microfacies and the diagenetic information that you can gain from cuttings can be really powerful for understanding deposition of facies and also reservoir quality. Now, we always recommend to our clients that we take full advantage of this data, especially where there is no core or sidewall core. So here at Cambridge Carbonates, the workflow for evaluating cuttings starts with the preparation of thin sections. Thin sections are prepared from a resin impregnated block. The thin sections are then stained using a mixture of alizarin red S and potassium ferrocyanide, which allows limestones and dolomites to be differentiated, with the limestones taking up the pinkish colour. Before undertaking the petrographic analysis of the thin sections, we next need to prepare the spreadsheet on which we record the observations. The sample depths are entered on the left-hand part of the spreadsheet, and the microfacies are typically entered along the top of the spreadsheet. We then use a colour coding to record the abundance of microfacies, red being the dominant microfacies, yellow being common microfacies, and blue being trace microfacies. We also annotate these with a crosshatch if there is any porosity. So step 3 of the process is then to undertake the petrographic work itself. And at Cambridge Carbonates, we have a number of different microscopes, but for our petrographic work, we tend to use this Nikon Eclipse 50 eye-pole microscope, which has a pixel-link camera attachment for taking photomicrographs, and we do love to take our photomicrographs. Now, we of course evaluate the cuttings thin sections at different objectives, and the intention is to record all of the different microfacies types and diagenetic features that we see in each of the cuttings. So for example, here we see some coated grainstones. Here we have some cuttings examples of anhydrite. Here we have some medium crystalline dolomite where the original facies are not easy to see. Here's some loose, very coarse ooids, and again an ooid grainstone which has some molded porosity developed, and some large ooids once again. So you can see that there is quite a wide variety of microfacies types which are present in this sample. So step 4 of the workflow is then to record the abundances of the microfacies in the spreadsheet that we had prepared earlier. So for example, in these shallower samples in this well, these are dominated by siliciclastic microfacies. We have dominant laminated argillaceous mudstones, we have common structureless argillaceous mudstones, and common arcosic sandstones. And we also see that we have some caved microfacies as well, and particularly these pelagic carbonate mudstones, which would probably chalk from a shallower succession. But in the deeper parts of the stratigraphy, we can see that the succession only has trace amounts of these siliciclastic microfacies, and it is dominated now by carbonate microfacies. So bioclase grainstones are common, peloid grainstones are common within the succession, and also have porosity, as you can see by the crosshatch that we associate with this microfacies, as well as bioclastic aranites, and the dominant microfacies type are porous bioclastic packstones. Not only do we record any microfacies, but any macroporosity that we might recognize as well. So in these examples here, examples of different types of bugs or fractures, and the recording of lost circulation material. Some of the key indicators of macroporosity are lost circulation material. Now, lost circulation material is typically added to the mud system in a well when drillers are trying to control mud losses. And some of the key features that we actually see in the thin sections include walnut shells, mica, or even bits of plastic. So when we see these in thin sections, these are all indicators that the well had encountered some sort of mud losses and hence macroporosity that needed to be controlled. Now, another lithological indicator of macroporosity is when we see an example like this, where we have either dolomite crystals or, for example, perhaps calcite crystals with these beautiful euhedral crystal terminations, suggesting that these crystals must have grown into open pore space, whether that be a vug or a fracture of some sort. So it's clear that we can gain a huge amount of information about the microfacies and the diagenesis from cuttings. And a completed cuttings microfacies spreadsheet might look something like this. So then our final step is to interpret the microfacies successions. Now, from this spreadsheet, an obvious observation is that there is a notable upwards change from carbonate microfacies at the base to siliciclastic microfacies at the top of the interval. So these are the larger scale sequences and cycles that we can recognize. But not only that, we can start to interpret some of the smaller scale cyclicity. For example, shallowing upward cycles, which have a lower energy bioclastic waxstone base through to a bioclastic grainstone top. And these cycles may then be repeated. So not only can we determine these larger scale sequences, we can also recognize these smaller scale sequences and any diagenetic overprint, any macroporosity, and also identify intervals of reservoir quality. So hopefully that's given you a flavor for what we can do here at Cambridge Carbonates with cuttings data. We still feel this is a really underutilized data source, especially when you don't have any core or sidewall cores. So we'd of course be absolutely delighted to discuss any of these techniques further with you. So please don't hesitate to contact us if you'd like more information. Many thanks for watching and have a great day. Thanks. Bye.